Welcome viewers, welcome to Physics World by Spark Sudhakar. Today we are going to discuss uh, something known as quantization in physics. It's a general topic. Okay. One of the years when I took one lecture on electric charges, when I said that charge is quantized in the multiples of E, okay, I received a doubt from a student. That's why please explain what is quantization. Yes, it's a simple question, but very useful question. Okay, and important also. Right, to understand what is this concept of quantization, what is the meaning of quantization. Okay, where do we come across this word quantization? First in 10th class or in 11th class or in 12th class. Okay, we say that Max Planck's quantum theory, energy is quantized. Okay, light is emitted in the form of tiny packets of energy, quanta. Okay, the energy of each quantum is equal to hU. This is known as Max Planck's quantum theory. Okay, and next thing we hear about what you call quantization is in Bohr's theory of hydrogen atom. We say that the angular momentum of the electron around the revolving around the nucleus is quantized as orbital angular momentum L equal to, right, mvr equal to, right, we say nh by 2 pi, where h is Planck's constant. Okay, right, this is where we come across the we what you call hear the words quantization in the beginning stages of learning physics. Okay, what is the meaning of this quantization? What is the meaning of energy quantization or angular momentum quantization? Okay, now forget about Max Planck's quantum theory or Bohr's theory. Forget about physics for that matter. In our everyday life, how is our everyday life? Is it quantized or continuous? What is the opposite word of quantization? Continuity. Okay, a wave, light is a wave means I say energy is continuous. We say, okay, according to Max Planck quantum theory, light is not a wave. Light is not emitted in the form of wave, but it is emitted in the form of packets. We call it. Okay, this is quantum theory. This is wave theory. Okay, a wave energy is continuous. In quantum theory, energy is discrete and discontinuous, we say. Okay, so forget about physics for some time. Is our everyday life quantized or continuous? Just guess. Okay, what do we see in our everyday life? Okay, continuity or quantization? If you observe it, okay, on the whole, life appears to be continuous in most of the cases. Okay, you can drink any amount of water you like, either one drop of water you can drink, or two drops, or half a drop, or 1 liter, or half liter. Whatever amount of water you want to drink, you can drink. Whatever amount of anything you want to eat, you can eat. Okay, there is no restriction, no, right? There is no, you won't find any restriction. Okay, you want to drink milk, any amount of milk you can drink, one sip or two sips or three sips, anything you can drink, or you can have 1 liter milk also, doesn't matter. Okay, right? So everything appears to be continuous. You can take any amount of energy continuously. We can take any amount. We can give any amount of energy continuously. Life appears to be continuous. Okay, but let us see that aspect from a different point of view. Okay, so I'll give you a rough example. Suppose say you go to a hotel. Okay, you order for one plate of idli or one plate of chapati. Okay, that fellow, suppose the idli costs 20 rupees per plate. That fellow will give you two idlis in a plate. Okay, that is one plate idli, or two chapatis he will give, right, for 20 rupees. So you will pay him 20 rupees. Okay, you will take one plate idli, right? After eating that, suppose say you are still hungry. You feel like eating more, okay, but you don't have 20 rupees in your pocket. Suppose say you have only 10 rupees in your pocket. Okay, 10 rupees. You cannot buy one plate. So big restaurants, they won't give you one idli, half idli like that. Okay, they'll say, sir, either you buy one plate or two plate. That's all. We cannot offer for anything for 10 rupees. But some roadside hotels or some small restaurants, they'll give, okay, for 20 rupees, two idlis means one idli extra, you'll charge 10 rupees and he'll provide you one extra chapati or one extra puri or one extra idli, he'll provide. Okay, so you'll suppose because you have only 10 rupees in your pocket, you will pay him the 10 rupees, he will give you one chapati, you will eat that also. Okay, I am also sitting there beside you, only say, okay, I also ate one plate chapati. Okay, but even I am also hungry, but I want to eat more, but I don't have 10 rupees with me. I have only 5 rupees with me, say. I have only 5 rupees. I saw that fellow giving you one extra chapati when you paid him 10 rupees. Okay, but I don't have 10 rupees with me, I have 5 rupees with me. Can I go and ask that fellow that for 10 rupees you have given him one chapati extra? Okay, I have only 5 rupees, so give me half chapati or half idli. Is it possible? Okay, will any hotel fellow will give you half idli? Okay, what will he say? Sir, either you take one idli or two idlis or three idlis, that's all. Not this half idli business. Okay, because if he gives me half chapati for 5 rupees, another third fellow will be there, he will have only 2 rupees with him. So what will he say? Sir, I'll take a small piece of chapati and give you, or small, I'll take a bite of idli and give you. Okay, that's not possible, no, that's not acceptable. So now tell me, are idlis quantized or continuous? Okay, idlis are quantized, we say. We can buy or give idlis only in the multiples of 1, 1, 1. Either 1 idli or 2 idli, 1 chapati or 2 chapati, 3 chapati, like that. So, chapatis are quantized. Idlis are quantized. Dosas are also quantized. Nobody gives you half business, no. Similarly, cool drinks also. A cool drink, a thumbs up bottle costs around 20 rupees. Okay, you cannot go to the shop filler and say, I have only 5 rupees with me, so I take 2 or 3 sips of thumbs up and give you, please give me. He won't give you, no, isn't it? Otherwise, he has to maintain one separate thumbs up bottle. Whoever pays him 1 rupee or 2 rupees, he allows them to take one sip and put the bottle there and go. Is it possible? These things are not possible, isn't it? Either you buy one bottle or 2 bottles or 3 bottles of thumbs up only. No half bottle, 1/4 bottle, like that. Okay, means that is quantization, we call it. Okay, things coming in, some fixed amount, some fixed minimum amounts. This one is quantization. Quantum in Latin means fixed amount. Fixed minimum amount is known as quantum. Its plural is quanta. Okay, plural is quanta. Okay, but after buying that cool drink bottle, okay, how you drink that cool drink depends on you. You can drink it drop by drop or spoon by spoon, or you can just gulp the entire bottle in one stroke into your mouth, doesn't matter. Okay, but interaction between two persons, okay, takes place in quantized form only. Okay, you can give or take one bottle or 2 bottles, like that. After buying the bottle, how we drink that cool drink, that's up to you. Okay, interaction between two different things is always quantized. Okay, same is the case with currency also. Okay, money. What is the minimum amount of currency we have in India now? Earlier we used to have 1 paisa, 5 paisa, 10 paisa, 25 paisa, charana, baratana, etc. Atana coins used to be there, charana coins used to be there. Okay, but now there is no 25 NP, 50 NP coins. There is minimum now, I think, 1 rupee coin only. Okay, we don't even care 1 rupee coin nowadays, isn't it? Okay, minimum amount is 1 rupee. Can anybody give 79 paise to anybody and takes 83.5 paise from anybody? Impossible. You may give him 10,000 rupees or even 50,000 rupees only in the multiples of 1 rupee. Okay, or other higher multiples like 5 rupees or 10 rupees or 20, like 100,000, 2,000, like that. Okay. So, what is the minimum amount of currency? That is called quantum of currency. In India, our quantum of currency now is 1 rupee. Okay, it is 1 rupee. Quantum of currency. So any transaction between two persons always happens in the multiples of this 1 rupee only. The multiples of this 1 rupee. That is, our life is also, everyday life, most of the things are quantized only. Most of the things are quantized. You cannot buy half pen or you cannot buy 1.5 pence. Either you buy 1 pen or 2 pens or no pen, that's all. Okay, like that. Most of the things are quantized only. Similarly, right, in physics also we come across energy is said to be quantized. Earlier, when things were about 100 years back, 120, 130 years back, people used to think that energy is continuous because it appeared so for them. It appeared so for them. Okay, but later on, some what you call phenomena in physics could not be explained. Okay, usually assuming that light is, if I consider light as a continuous energy thing, okay, certain phenomena could not get explained. So Max Planck has come out black body radiation. Okay, light as a wave was successful. How many properties are there for light? Okay, somebody has understood light means how many properties of light you should understand. Light always travels in straight lines. Rectilinear propagation of light. Next, reflection of light, refraction of light. Okay, interference, diffraction, polarization. These are the 6 aspects of light. Anybody can, those who has studied all those six aspects can say that he has studied about light. Or any theory about light should be able to explain all these six properties of light perfectly. Okay, initially Huygens wave theory could explain all the six properties of light perfectly. That's why people thought that light is a wave, light is energy is continuously emitted or continuously absorbed by the source emitting light. Okay, and with the help of this Huygens wave theory, people could explain all the six properties of light perfectly. Okay, but in about 1880s and 1890s, a new phenomena were observed, like photoelectric effect. When this light goes and falls on a metal plate, electrons are found to come out. Okay, electrons are coming out means what? They are getting energy from where earlier they are not coming. This is a metal plate, say. Okay, there are some free electrons inside. Okay, they are not coming out on their own. When I send some light of suitable wavelength, then electrons are found to come out. Okay, electrons are coming out means they must have got additional energy. Where from they have got additional energy? From the incident light only. Okay, but if I treat light as a wave, because wave theory was successful in explaining all the properties of light, if I apply that what you call wave theory and try to understand this photoelectric phenomenon, I could not understand. Means people could not explain successfully all the salient features of photoelectric effect could not be explained properly. Okay, why wave theory is failing? So-called highly successful wave theory, why has it failed? Okay, in explaining photoelectric effect, people could not understand initially. Similarly, there is something called black body radiation. Radiation emitted by a perfect black body. Okay, if I apply wave theory of light, right, we are not getting correct results. Okay, so looking at all these things, especially looking at black body radiation, this Max Planck, a German physicist, came out with the idea that what happens if light is not emitted continuously, if light energy is not continuous but it is quantized. Earlier Newton also tried the same thing and failed. That's why what you call Max Planck has approached this problem in a different way. Okay, he did not call light as a particle, he simply said a packet of energy, he said. Okay, that's called Max Planck's point. He said, right, Max Planck's quantum theory, he said that light is not emitted in the form of a wave like this, means energy is not coming out of the source continuously, but energy is coming out in the form of tiny packets. In Latin it is known as quanta. Okay, one packet is called one quantum. Okay, right, energy of each quantum is equal to h nu. Equal to h nu means a source of light is there. Right, earlier people thought that it emits energy continuously like this. Okay, now quantum theory says what? No, this cannot emit energy continuously. It emits in the form of tiny packets, like just like our one idli, two idlis, like that. Okay, not continuous, just like water coming out of tap. Energy is not continuously. Energy is coming in some fixed amounts. That is quantum. That is quantum. Okay, what is energy of each quantum? Equal to h. Similar later on, that is energy is quantized. We say means energy is given continuously, not continuously, but in some fixed amounts only. Okay, that's known as quantization. Okay, right, later on Bohr has proposed that apart from energy, angular momentum also should be quantized. Okay, with the help of that postulate or assumption, Bohr could successfully explain the hydrogen atom, spectral series of hydrogen atom perfectly. Okay, he said that angular momentum of an electron around the nucleus, right, is also quantized as nh by 2 pi, n equal to 1, 2, 3, etc. Okay, this h by 2 pi sometimes written as, right, h bar. It is written as h bar. Okay, right, either means angular momentum can be either 1 h bar or 2 h bar or 3 h bar, that's all. It cannot have any other value. It cannot have 1.1 h bar or 0.7 h bar or 2.5 h bar like that. Okay, either it should be 1 h bar or 2 h bar or 3 h bar. This is known as quantization of angular momentum also. Angular momentum also should be quantized. That is the geniusness of what you call Niels Bohr, greatness of Niels Bohr actually. Okay, he came out with that idea that what happens if angular momentum is quantized. Okay, when he is taken quantized angular momentum, right, he could explain the spectrum of hydrogen atom perfectly. Okay, so angular momentum also got quantized. Okay, now we'll get a doubt. Now, but still, when we are studying optics, when we are studying about what you call interference or diffraction or polarization, we treat light as a wave only, even today also. Okay, in entire optics we use what you call wave theory of light only. Okay, even EM theory also we use. Entire communication systems what we depend on now are based on wave theory of light only. We treat light as an electromagnetic wave, where electric field and magnetic field vectors are vibrating perpendicular to each other and perpendicular to the direction of propagation. That is, light is a perfect transverse electromagnetic wave, we call it. Okay, there I'm using wave concept only. Okay, even today also we use wave concept. We go to electronics engineer, they'll draw even the radiation pattern also. Okay, they have where is the intensity more, where is the intensity less, etc. We can draw radiation patterns. Means we are treating light as a wave only. Now, in order to explain photoelectric effect and what you call black body radiation, Max Planck has come out with this concept of quantization of light energy, radiation energy. Okay, right? Energy coming out, source radiation is quantized, he said. Okay, each quantum of energy is h nu, he said. Now, which one should I use? Okay, that's what, right? Later on, initially, that's why people were not ready to accept this Max Planck's concept of energy quantization for some years. Okay, but later on, a photoelectric effect has come. Einstein has used this quantum theory and explained photoelectric effect perfectly, for which he got Nobel Prize. Einstein got his Nobel Prize not for relativity or for any other thing. For photoelectric effect only, he got his Nobel Prize. Okay. Later on, Niels Bohr also has used this quantization idea, quantized energy in hydrogen atom, and moreover, he proposed that apart from energy, angular momentum also should be quantized, he said. And he was successful in explaining hydrogen atom. Okay, means quantum theory started gaining more and more popularity. It's becoming successful more and more in more and more areas. But when I go to interference or diffraction or polarization or reflection or refraction, wave theory only is found to be convenient. So people got divided over this. Is light, which theory should be accepted? Whether I should accept quantum theory or whether I should accept wave theory. Wave theory has its own advantages and disadvantages. Okay, quantum theory has its own advantages and disadvantages. Okay, I use quantum theory, I can easily explain black body radiation, I can easily photoelectric effect, hydrogen atom, etc. But polarization of light, okay, interference of light, diffraction of light using quantum theory becomes difficult, and they were very complicated in those days. So there are two theories. This is good in some aspects, this is good in some aspects. Okay, which one to be followed? Means people would not take a decision. That's why for the first time in physics, the concept of dual nature of light has come. Light has dual nature, they said. Dual nature, actually in physics we don't accept such things. Physics and mathematics are exact sciences. Okay, right? I cannot say 2 into 2 means 2 into 2 is always 4 only for anybody, everywhere, always 2 into 2 is 4 only. No, you cannot say that no, sir, in our village we take it as 4.5 sometimes, or in coming December we take it as 3.5. Once we go to January it will be 4.5, not like that. Okay, 2 into 2 is 4 always for everybody, everywhere. Isn't it? It's an exact science. Okay, right? Similarly, physics also. V equal to U plus 80 means V equal to U plus 80 only, that's all. Okay, when you throw an object up, right, the object has to fall down due to gravity, that's all. As long as we are on earth, anything thrown up should fall back. Okay, there is no guarantee. If you say, no sir, when you throw this pen, there is no guarantee that you should fall back, it may go like that. What do we say? No, we don't say it like that, isn't it? What do we say? Any object thrown up has to fall back. These are all exact sciences, isn't it? But here, for the first time in physics, scientists were forced to accept what is known as dual nature of light. Means light sometimes behaves like a particle, sometimes behaves like a wave. Wave means energy appears to be continuous. Okay, quantum means what you call photon. Quantum theory means energy is quantized in the form of packets. Each packet's energy is equal to h nu, we say. Okay, like this, dual nature of light has come. Okay, light has dual nature. How do you understand this? Okay, how do you understand this means? Even now sometimes we use quantum theory, sometimes we use what you call wave theory, because wave theory becomes very useful in explaining some aspects in communications. Okay, so how this problem is resolved now means, when light is propagating, suppose a light is emitted from sun or light is emitted from this bulb. Okay, when light is traveling, treat it as a wave. It's okay. It will give you correct results only. You will understand all aspects of light. You can explain its properties also. When this light goes and falls on some particle or interacts with some matter or material particle, then it is convenient to use quantum theory. Means treat that light is a quantum fixed amount. Light is a quantum or fixed amount. So when light is propagating in free space, treat it as a wave, no problem, you can understand everything about light. But when that light goes and falls on some object and starts interacting with that object, gives its energy or tries to take energy, then instead of wave theory, we have to use quantum theory. That becomes more useful. Things become easy. Okay, right? So what is dual nature? Dual nature means we need not bother what is light actually, is it a wave or a particle? We need not bother. Light has all these properties. You want to understand light means what are we supposed to do? Light behaves sometimes like a particle, sometimes like a wave. Okay, you want to understand more about light, we have to study both aspects. Okay, right? We should not wait for somebody to come and confirm that whether no, it is a wave only, it is a photon only. It need not be. Okay, right? This is also light property only. That is also light property. Okay, you want to understand everything about light, so you are supposed to study both, and you should know where to use which theory. As long as light is propagating, treat light as a wave, no objection. That's why communications are using wave theory. Okay, when that light goes and falls on an object and starts interacting. Interacting means what? Giving some energy or taking some energy. There, quantum theory is useful. Okay, light should be treated as photons. Means light is emitted in the form of packets or absorbed in the form of packets, we say. Each packet is quantum. Okay, quantization we call. Fixed amounts only. Okay, so interaction will be in terms of fixed amounts. As I told you, we can give or take money in terms of 1 rupee or 2 rupees only. We cannot give any amount. 1.25 paise we cannot give now, isn't it? There is no currency at all. 1 rupee is the minimum currency, minimum quantum. Okay, similarly, minimum quantum of light energy, h nu we say. Okay, so this is about quantization. Okay, this is a general topic. We'll further continue with our electrostatics 3. Okay, in the next video. Thank you.